show you how to hook up a Micrologix1400 to an RMC75e. I started up a new project in both programming softwares. The Micrologix1400 will open up over here. Over here I'll just quick fly through and start up another project just so we can get this going. Show you how to do it to a 75E. The concept transfers over. This is just basically how you would want to set up in order to communicate and pass data. The RMC75 has 64 words of data that you can transfer back and forth. You can dictate how much is what. Usually, I know when you first start up this, if you just went and downloaded it, the RMC Tools software is free at deltamotion.com. It's free download, but if you start it up, it usually comes out the box IEC, so you're going to see a %MD18. If you want to look at that in the Micrologix format, just go over here to DF1, and it'll give you an F18 number here, which is pretty nice because you'll see how it makes it a lot easier to follow what's going on here. Once we got that done, let's head over to the Micrologix and we'll set that side up first. So let's make this a little bit bigger here. We're going to need some new data files. We want to add one specifically to data file 18. We're going to make them floats. We'll call this our RMC data. There's 64 words that we're going to pass back and forth, so we'll make this 64 elements big. Basically what we're going to do is split that data file in half for read, half for write. We are also going to need a message file. We'll need two of those message files, one for read, one for write. We're also going to need a route file. The names I'm giving these, this RMC route, this RMC data, these are not specific. You can make those whatever you want. I just use them like that so we can follow along. Because multiple controllers, it may be something else, you know. So just so you know, it doesn't mean anything. You can call it whatever you want here. So without that, let's see, we get in here, here's our data file. We're going to have 0 through 63. There's our 64 words. Like I said, I'll split the controller in two, so from 31 on, we'll either read and write, and from 0 to 31, we'll do the opposite. So since we have all those set up, we can come in here, let's go ahead and type a message file out. MG90 is the message. We'll start that one first. We'll just say this is our read data. So now you have to decide, where do you want to do? Do you want to read first or do you want to write first? Well, in Motion you probably want to read first because that's going to update everything before you send your control. So hey, what's going on, then control. Hey, what's going on, then control. Instead of control and then hey, what's going on. Hey, control and then what, you know, we don't want to be behind the ball, we want to be in front of it. So let's read first. And the address format here, we're going to go ahead and just make this straightforward. F18 on this controller is where I want my data to come from. We do integral ones, and it's going to be 32 words because we want half that controller, we want to split it. Now on the target device, we want to keep it the same, F18 and the reason for that is because if we split screen here, you'll see it'll correspond. So if we start here at F18 from this controller, and you say that this F18 in this controller is equal spot, then that makes it a lot easier to follow. So we'll say F18.0 here on this controller is where I want F18.0 here to be. Well, it'll read this over to F18.0 on the controller there, because it is a read statement. So when I say read, the PLC will communicate and say, give me 32 words starting at F18.0, and it'll come out. So we also need a routing information. We're going to use our route file R10. Now this is going to need a multi-hop setup, our IP address to the RMC, and that's basically all you need to do to set up a read. So let's close that down. We'll go ahead and copy that and paste it. I know you can't see it, I know what's going on. Let's put this back to normal so you can see it. This will be our second message file. This is going to be our write. Similar setup. Differences are you're going to make this a write. It's still going to be an integral 1. The multi-hop is still going to have the same there. F18.0 now becomes F18.32, because then what it's going to do is it's going to start at F18.32 here for 32 bits, taking you out to 63, and it's going to send that. Where is it going to send it? It's going to send it to F18.32. So if you come down here, it's going to start. It's going to populate from that point to this point. It's going to be starting on this controller. Whatever data you put into that register will appear on this side in this register. Just the same as when you populate something on this side in this register, it'll populate on this side in the register from the read statement. So that should all be set up. That's all we really need. And then to make these triggery, and we always send them constantly. If you have a lot of communications going on, I don't suggest you do this. This is going to flood. I keep sticking that 19 in there. That's not what I want. 90. There we go. That's what we're looking for. You copy that, paste it. It didn't give it to me. Micrologix loves to get you like that. You know you're on it. You know you copied it, but it still saves whatever you had copied the last time you pasted. So we want to change this back out to the right message. Now what's going to happen here is this isn't going to be done. So this will be true, sending through and enabling it. Once it sends out and becomes complete, the done bit will go good, which then will knock this rung out. And then it'll subsequently, through the next scan, after the rung is false, this isn't done any longer, then this will come true again, which will enable it until it gets done, and it's a repetitive function here. So this is going to mass broadcast across your network, just so you know. You can condition when you're sending your data and when you're receiving your data, vice versa, when you're sending your data and receiving your data. You can condition that so you're not broadcasting as much, but for this demo, this right here is going to get your data moving. So that's pretty much all there is on the PLC side to set that up. Now let's go over to this Delta Motion controller. On the Delta Motion side, we're going to want to open up our modules, right click on the CPU and go to Properties. We want to make sure that this is going to be where I need it to be. This would be the IP address of my processor. Let's see, this all looks good. That all looks good. Next thing we're going to do is where we're going to actually set up the data transferring. That's going to happen on Ethernet IP. So the incoming cyclic data is the data that's being written from the PLC, and the outgoing cyclic data is the data that we're sending over or that's being read on the PLC. What you want to do is you want to tell it where on this controller where this is going to happen. You can see it's in the MD percent, or the %MD IEC format. Just envision this as being an F, and that'll help you out when you're setting this up. So you know your read, if you come over here and you look at the setup, what's your read? Your read is what's going to be written from this controller, and your read from the target device, which is this controller, is at F18.0. And the nice thing about it is if you write it into F18.0 here, if you accidentally look at the wrong side, you still get it right. So knowing that, you can come back over here, and the outgoing, what we're sending out, or what's being asked to be read, is going to start at F18.0. The incoming is going to be starting at F18.32, and it's going to be the same thing. When we write a message, this message file is going to go into this controller, the PLC, at F18.32, and it's going to take 32 words starting here, which will take you all the way out to 63. So all the data you have stored in these registers, and it's going to chunk that, and then it's going to send that out with the target of F18.32. And if you keep that the same, you can say, you know, this is F, that's 1832, and you know it's going to put it right here. So with that set up, you come down a little farther, and you'll have this sync register. For this demo, you're going to want to turn that off. You don't need that right now. I can go into that a little bit later. That's more for controlling when the registers are able to update. That should be all we have to set up on this controller to get it to pass the data. Now there's a little bit more stuff you can do over here once you have the data in the Delta. Now you can start tying it to the variable table where, you know, you already said that whatever's in F18.0 here is going to end up in F18.0 here, but you can map to, which is nice. It's almost like an alias. You can look at it like, so let's say we want to map that into a variable table. Well, we can map that right into here. We'll hit OK. So now if you open the variable table up, you'll see you map that to this place right here. And if you were to go, and you can change your address format here too, there's 56.0. There it is, 56.0. So you'll see that's in the IEC format. So when you look at the variable table, you can put that back to the IEC format, and you'll be able to find out where that goes. Well, here, let's just say you wanted to make that a variable for anything. That can be your position to travel to. So you'll say that's your demo position. Now once you have it in there, you can get into your user programs. We'll just hit, you know, get a regular one going, and if we get into the conditions here, you can see that if I go to that variable table, you can pull up that variable, and that variable will be mapped over to the indirect data map to this point here. So that variable will continuously change to whatever is being written, or, well, in this case 0 is a read, so this is what's going over there. It'd be sent, just continually sent, and when you use it in your programs, whatever value this is, that value is what's being continuously sent over to the other side. So that's how you pretty much hook up the two controllers. Any questions? If I left anything out, feel free to comment.